It's easy to see how Apartments.com is the best site for renters because with virtual tours, it's easy to find a new space without leaving your place. Virtually view floor plans and amenities with 3D tours and explore HD videos and photos, including interiors, neighborhood images, and even drone footage of exterior views, all from the comfort of your couch. It's that easy. Visit Apartments.com and get into a new rental today. Apartments.com, the most popular place to find a place.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk. Neil Degrasse Tyson here, your personal astrophysicist. Got with me my co-host, Chuck. Nice.
Hey, Neil. What's happening?
All right. I love having you out there, Chuck.
I love being here, man.
For all my Star Talk needs, you're there.
Oh, and beyond.
And beyond.
And beyond, my friend.
We're going to knock out another Cosmic Queries, but this one, we have to grab the ones that don't fit any categories. So this is just, I think you coined the term galactic gumbo.
Dude, that's my favorite. We call it grab bag. We'll call it a bunch of different things, but my favorite is galactic gumbo. You don't know guarantee. They'll put on there the little cayenne pepper.
Spice that up.
Spice a little cayenne pepper. Common cayenne pepper. That's a kind of common cayenne pepper.
So we should go to Louisiana and see if we can get galactic gumbo on somebody's menu.
Oh, wow. That's a great idea.
I mean, why not? Who's going to say no to that, right?
Exactly. Yo, that's a great idea. Oh, nothing would make me more happy than to go into a place.
A little bit of everything.
Yeah, galactic gumbo.
So these are all Patreon questions, and they're getting it good. I'm just looking at.
They are, but this time we actually we have more people than Patreon.
Oh, you let in some others in this round.
Yeah, this round. Because it's Ask Anything.
Okay.
So,
all right. And if I don't know, I'll just say, I don't know. Go on to the next question.
Yeah, that's right. So it could be anything that they want to know from you, you know?
Mm-hmm.
So, including, why is the sky blue? But we already did that.
We got that.
Yeah, we did.
And, the more content we post, Chuck,
right,
in explainer videos and things, the whole Cosmic Queries could just be, go to this link.
Go to that
and we just kick back.
Right.
When we're done explaining everything, then we got it.
Yeah.
Okay, so give it to. Oh, by the way, I'm compelled that this format inspired a book, a Star Talk book called Cosmic Queries. It's
nice.
March 2021. So,
and is it actual queries from people?
No, so what happens is there's some queries that are just so deep and they spill out over this format. If someone says, what is the meaning of our existence, or why is the universe here? Those are real questions that real people have,
right?
But they don't lend themselves to our repartee, right?
Gotcha.
So we collected the deepest questions ever asked, and we put them in the Cosmic Queries book. Ooh. So it's like, how did life get here? What is the universe made of?
Why can't I wear brown shoes with a black tuxedo?
Or can I wear white after Labor Day? Those are the questions.
The burning
that
questions.
Get asked.
Right.
Okay.
Cool, man.
All right, so start it out. What you got?
All right,
bring it on.
Let's go with Umran Coca. Umran Coca. But it says, Chuck, if you're reading this, please just call me Sarah.
Okay. Okay.
Well, there you have
Sarah.
it.
Thank you, Sarah.
Thanks, Sarah.
Thanks for telling me after you make a fool of yourself.
Right. You could have just put that as your name. Okay. All right. Could dark matter be the effect of another universe's gravity on our own gravity?
That's what I want it to be. I so badly want dark matter to be regular matter in a parallel universe whose gravitational force is spilling into our space-time. I want that to be true. But none of my colleagues are leaning that way, and they're like deep in it, and it's their expertise, and I'm just looking over the fence. What you up to today? Picking it up so I can share it with all you good people. So the what's the over-under, the odds-on favorite is that there's some other kind of particle, family of particles that are not the electron, proton, neutron, the ones we're familiar with, that do not interact with our particles. And if they don't interact in any sort of chemical way, then light will pass through them. All you'll feel is their gravity. Mm-hmm. And so I don't have a problem with that. I don't think it's as fun as thinking there could be another universe. Now, the only reason why I think this is I spoke with some top folks about field theory. This is a class I never took in graduate school, and I regret it. But field theory, you study, fields. These are fields that generate forces on objects, basically. Okay.
Not the kind you play on.
Not the kind you play on.
Okay, all right.
These are force fields. A concept introduced by who's our guy at the mid-century? Michael Faraday,
right,
in the mid-19th century, because no one imagined describing something you can't see that has an effect on other things. All right, and so he had to invent this concept, this field concept, where you draw lines that take the shape of that field, and that's what the iron filings do
for the magnetic field, right?
Right. Yeah. Before him, it was just that's just what they do.
Right.
But he gave
magic.
it. So he gave it. So he anchored it in physics speak, so that we can actually calculate with them and do other things.
Sweet.
So these are fields. So in field theory, you apparently, and I can't demonstrate this to you. I can only repeat it. Others have told me that light and all the forces that surround it, electromagnetic forces, cannot exit your space-time. They're trapped within it. But gravity can. Gravity can spill out of your universe and move between universes. That's what I heard. And I think I got that right.
Okay.
But so if that's the case, then a nearby universe in this higher dimensional construct could have gravity spilling into our universe. And there we are mystically touching it, thinking it's a magical, invisible thing, when it's just real and it's just something sitting on outside the door.
Wow. So now let me just ask this on top of what you talked about.
What Sarah
says. Thank you, Sarah.
Sarah.
So you say that some think that they might want it to be these particles that we cannot interact with.
Yeah, it's not so much that I think there's good reason to think they could be those particles, and there are experiments now designed to try to capture them and see if one in a zillion encounters with our particles, maybe they'll have there'll be some exception to that rule that'll render them visible.
Gotcha, because that's my point. It's like, why make that postulate in the first place?
Yeah. I mean, why not just little gremlins? I mean, there's an invisible particle, you can't see it,
right? So all right.
No. So you have theories guiding these experiments, and they're suggesting if the dark matter is of this kind, it should interact with this regular particle in this way, this rarely or this frequently. And so you do this. So we have these huge experiments trying to detect dark matter particles.
Okay, cool.
That's all that's going on there.
All right.
So I'm with Sarah on this. It'd be cool if it were.
Okay, very cool.
Yeah.
That is awesome.
By the way, if that's the case,
yes,
since we have 5 times as much dark matter in our universe as regular matter,
right?
That means there's a shit ton of regular matter in this other universe.
Right, their regular matter, right.
Yeah, if our dark matter is their regular matter, that universe has at least six times the mass of our. At least. It turns out to escape your universe and enter another one, the strength of the gravity drops off precipitously, so it has to be even stronger than just a factor of 6.
Wow.
So it's a honkering universe. And wouldn't it be weird if one day we learned we're just some small gnat among other gnats on the back of a much larger, more powerful universe, and we're just a satellite universe to it.
Wow, that's in a way very humbling.
Very humbling.
And in a way, I kind of want us all to get together and just make a very loud sound so that we're not boiled in a pot of water as the dust speck that we are. So,
or to get swatted off the back.
Or to get bang. All right. Wow. Okay, cool.
All right.
Okay, here we go. This
Give me
is
some more.
also from Patreon. Sarah was a Patreon patron. And for those of you, since we are allowing this to more than Patreon patrons, for those of you interested, go to patreon.com/Star Talk Radio and support us. And then, you can be part of actual private Patreon cosmic queries where Neil answers your questions almost personally. So there you go.
Yeah. These would just only be posted behind the
behind the
Patreon
curtain. Behind the curtain. Yeah, Patreon curtain.
Mm-hmm.
All right. Fernando Gomes says this.
Gomes or Gomez?
It's Gomes, so maybe it's Gomez, but it's just
if it's Freddie Gomes, then fine. But if it's Fernando, give me some.
Okay. All right. I'm sorry. Allow me to recalibrate. Here we go. This is from Fernando Gomez.
Now starring Fernando Gomez.
Right.
No, maybe Gomez needs a Z and Gomes is F.
I don't know.
Okay, go on.
Anyway, he says, our own pocket of the universe is expanding. Will it exceed the speed of light? I guess when he's saying expanding, he's also including the acceleration as well. And if so, will that mean we'll no more be able to detect anything coming from outside of our universe too?
First of all, that is already the case.
Oh,
okay.
Snap.
Okay. And as time moves on, and as you correctly added, Chuck, with the acceleration of the universe, what will happen is things that used to be within our horizon simply expand faster than the light that they're sending us can reach us, and then they basically disappear beyond the horizon. And as the universe continues to expand, things that used to be nearby will now find themselves on this extreme limit of the expansion and then disappear beyond the horizon, such that there will be a day that arrives. By the way, there's a whole section of one of the chapters in the Cosmic Query book on this. By the way, it's not out yet. It's like March, so don't worry about it yet. It's not out yet. So I don't even think it's listed yet. So I shouldn't even be talking about the book. So pretend
No, you guys.
I didn't say anything.
Hey, you're getting a sneak peek. Don't worry.
Okay, so there comes a time when our galaxy will merge with the Andromeda galaxy, it becoming one galaxy twice the size. And it will become only us in our pocket of the universe. And all other galaxies would have receded beyond our horizon. And the night sky, as seen from Earth, would contain only stars and nothing else in the universe. So we would have a universe that people thought it was before Hubble discovered other galaxies. There was a time, ask anybody before 1926. They say, tell me about the universe. Well, they're just stars.
Right.
Stars in the night sky, and stars just go on like forever. And then we learned all the stars you see are in our one little galaxy. Right. And there are other island universes, if you will, which was a term traceable to Immanuel Kant and others back in the 18th century. Could there be island universes out there? So other galaxies, you can think of them that way. And so everything we know about the history and origin of the universe is because we can see these other galaxies out to the edge of the universe. But in the distant future, when they all recede beyond our horizon, gone is any record of the history of the universe, the Big Bang, the expansion, everything. There'll be no indicators left to tell us. It'll be an entire chapter of the history of the universe ripped from the book.
Oh,
and God. There you are. Any post-apocalyptic civilizations will say, yeah, the universe is just the stars in the night sky.
And they won't have any way to disprove that.
And Chuck, I lose sleep wondering whether we today are in some kind of state of existence where a chapter had been removed from our attempt to probe our place in the universe. And here we are without that chapter trying to make sense of it.
Oh, that's terrible.
Terrible.
What a terrible, Terrible thought.
I have these thoughts, and it delays slumber many a night.
That's just awful. That's an awful thought. Oh my God. Yeah. And so is the distant future thought. That's not good either.
Right.
Yeah.
I got another one. You ready? Suppose you grew up on Venus. You'd be vaporized, but let's ignore that complication.
Okay, right.
If you grew up on Venus.
I got some really good sunscreen.
if you that won't help you from high temperature.
This is true. That's only UV.
Sunscreen ain't stopping you from
right. That's not 900 degree.
That's not a
yeah. I got an asbestos bathing suit. Go ahead.
So, if civilization arose on Venus,
right,
there would be no culture of the night sky. There would be no night sky because it has such a thick cloud cover. No one has ever seen the night sky.
Oh, wow.
All you would know is that half a year, because Venus rotates very slowly, half a year it's just kind of light, and then it gets dark for most of the year, and then that's all you're going to know. And so someone would have to figure out how to travel in space to even know there's such a thing as traveling in space.
Right.
Build a spaceship and then imagine emerging from those clouds, the cloud tops for the first time. And you see the sun and stars and other planets. Oh my gosh. So are we buried under some cloak preventing us from getting an accurate understanding of the world around us?
Wow. That's very very profound and thought-provoking. And
yeah, that's Fernando.
There you go, Fernando. Look at you, buddy. Nice job.
All right, we got to take a quick break. When we come back, more Cosmic Queries, Galactic Gumbo edition.
Now home
on Star Talk.
With Masterclass, you can learn from the world's best minds anytime, anywhere, and at your own pace. You can learn photography from Annie Leibovitz, or writing skills from David Sedaris, or even up your tennis game with Venus Williams. With over 90 classes from a range of world-class instructors, the thing you've always wanted to do is closer than you think. You can even find a course from world-renowned astrophysicist Neil Degrasse Tyson on scientific thinking and communication. And each class is supported by downloadable materials, lessons, or recipes, and more, all available anytime, anywhere on iOS, Android, desktop, Apple TV, Amazon Fire TV, and Roku. I took the class on the art of negotiation with FBI international kidnapping negotiator Chris Voss, and now I can't wait to be abducted. All right, seriously, I learned a lot of things that I never considered, and I highly recommend you check this out. Get unlimited access to every masterclass, and as a Star Talk listener, you get 15% off an annual membership. Go to masterclass.com/StarTalk. That's masterclass.com/StarTalk for 15% off.
Hey, I'm Roy Hill Percival, and I support Star Talk on Patreon. Bringing the universe down to Earth, this is Star Talk with Neil deGrasse Tyson.
We're back, Chuck.
Yeah.
Chuck, do you get to do stand-up during COVID? How does that work?
Okay, so it's so funny that you asked that. I have done a few Zoom shows, to be honest, and they feel weird. Mm-hmm. And I am
because so much of your business model as a comedian is interacting with people and seeing them and feeling them. Right? You can't do comedy in a vacuum.
No, it's weird. And but on Zoom, that's kind of fun because depending on who's hosting the show, sometimes they let you can see into these people's homes, and so. Do you smack talk? What's going on? That is so much fun. There's so much fun. It's like, it's like, if I were doing a Zoom right now and a comedy show and I'm looking at Neil deGrasse Tyson, I'd be like, oh, look at that. There's Dr. Tyson, who apparently has pictures of alien sperm on his wall, which is, that's great. That is fantastic. This guy's clearly been off the planet, Okay. So, that's the fun part. But it's not nearly as fun as doing stand-up live with the energy of a live audience. There's a real human connection that comes with a live audience. There's nothing like that.
Mm-hmm. So just for those only listening, I have two works of art from an Inuit artist.
Yes.
And it is a bird that has just consumed a fish, and one is a black and white version. The other one is a white and black version of the same print. And they flank my desk.
Yes.
For these recordings. And they do look a little alien.
Yeah, they do. They look a little alien, but they're cool.
Yeah. And if you're interested in these, you can find them on our postings, the name of the artist and a little bit of the history of the Inuit culture is there. So,
sweet. Very nice.
And I thank her for giving me permission to show these. They're real art. My wife is was raised in Alaska.
That's right, yeah.
So she has sort of an awareness and a sensitivity to the whole region and Inuit art and this sort of thing. So
that's cool.
Yeah. Cool. Let's keep going. Give me some questions.
Yeah, let's get back into let's do another Patreon from Jet Thomas. What a good name. He's a space hero. Hello, Neil and Chuck. If gravitational waves can bend the fabric of space-time.
Wait. By the way, jets don't work in space, just so you know. You need rockets, but go on.
Okay, you're right, because you need an air inflow.
You need air.
You need air inflow to make a jet.
I'm just saying.
I got you.
Okay.
Listen, I'm not. I will take that correction. I know.
I'm gonna be all up in your face about it.
I know. Listen.
I won't let stuff go by.
I know who I'm talking around.
Okay.
That's why I don't go to the movies with you. All right, here we go. So Jet Thomas says this: if gravitational waves can bend the fabric of space-time, could it potentially be utilized to communicate with life in other universes? In principle, could a device use gravitational waves instead of the way we use radio waves to stream information outside the bounds of our universe? Now, you just said in our previous answer that light is bound to this universe, trapped. Yes. So now, gravitational waves.
Yeah, so each one of these is an entire window to the universe. I mean, let's think back for a minute. When the telescope was sort of pioneered by Galileo, he's thinking, oh my gosh, look what I can now see. And I can see ships farther in the distance. I can look up at the Milky Way and I see stars where you thought it was just a cloud. Mm-hmm. And he's imagining that the telescope is the way to see everything your eyes can't. Okay?
Right.
But then, give me a couple hundred years on that. And then what happens? William Herschel discovers infrared, which is also light, but your eyes can't see it. And in fact, in his original research paper, he called it light unfit for vision.
Wow.
And so, wait a minute, if all your telescopes are only giving you visible light, but why even call it visible light? It's just light, right? You don't have any other, there's no reason to qualify that it's visible light if you don't know any of the light that you can't see. The moment we discover light you can't see, you now have to constrain how you call the light your eyes detect, and we call that visible light. Infrared is not visible. Ultraviolet is not visible. Neither are X-rays, gamma rays, radio waves, none of that. Yet it's all light, traveling at the speed of light. So we open up telescopes to these windows to the universe, and that's how we discovered the birth of the universe and black holes and jets and all kinds of things in the universe. That's how we discovered them. But now we can go a step beyond that and say, all of these collectively, in a way, is just one kind of window to the universe, the window that uses light. Are there other kinds of windows? And yes, gravitational waves is a kind of window. Neutrinos is a kind of window. There are neutrinos everywhere. We just need special telescopes to detect them. And so if gravity can escape your universe, if that can happen, then there's no reason why we can't send a signal. I agree entirely. That's a long answer to just say yes. I agree, but I got a question that, again, I'm an idiot when it comes to field theory. So if the ripple of a gravitational wave requires, or its effect in the space-time continuum is this wave, when it leaves the universe, what is it jiggling? I mean, I don't know what is it. Maybe it's just the graviton. The quantum particle that corresponds to the gravity wave, in the same way a photon of light corresponds to the wave of light, right? These are sort of parallel constructs, right? We speak of light waves, they're carried by photons. Gravity waves carried by gravitons. Maybe the graviton busts out, goes through, enters the other universe, and we don't have to worry about the wave warping the fabric of space and time. So, yeah, I don't see why not. But I would need higher expertise to answer that with some precision.
Wow, God, how much higher expertise can you get?
We got people.
Jesus.
Brian Greene would totally.
Oh, yeah. Well, yeah,
that is
his
he's just
thing.
up the street.
Yeah. That's his thing. That's right. Yeah. That was a great answer, though, man. That's fantastic. Yeah, I love it. And the windows to the universe, that's an excellent.
Yeah, so what it is, it's a window. So the electromagnetic spectrum is a window of windows.
Right.
Right? And then we have another kind of window over here on the other side of the house.
See? Man, I love that. I love that. That's just, God, that's so...
If you went back in time and said, Galileo, you're practically blind.
Right.
And he'd say, no, I'm not. Look what I can see.
He was like, do you not see what I'm looking through? What the hell is wrong with you? Yeah.
That's exactly how he would have said it, too.
You know that's how he...
Dude!
What?
He was colloquial, by the way.
Yeah.
He hung with the common folk.
Oh, really?
So he might have spoken in Italian vernacular of the day, whatever that would have been.
Yes, the Italian equivalent of "child, please." So, okay, cool.
Child, please.
Child, please. Don't you know I invented the telescope? The hell is
Straight
your
from
problem?
the inner cities of 20th century. Child, please.
Oh, that's hilarious. Okay, here we go. I love that, the different windows of the universe. Love it. Okay, let's go to Eric Allen. Eric Allen, also from Patreon, and then we're going to jump into other people outside of Patreon. I'll make Eric the last Patreon question. Hi there. I've been listening for years, and I finally have the nerve to ask a question.
And who asked this?
Eric Allen.
Eric Allen. Very
Yes.
nice. Okay.
So thank you for listening, Eric. Here we go. He says, we know that the force of gravity bleeding into our universe from another universe would drop off at the rate of 1/r cubed, he says. Yeah. Okay. Hypothetically, if the other three forces were somehow able to bleed into our universe from another, would they be affected the same way? Now, I don't know if I said his equation correctly.
And I got it. No, we're good. We good here.
Are we okay?
So let me just say what's going on here.
Yes.
Okay.
Please.
Okay. If I have a water pistol,
Okay.
and I shoot it right at your face,
Right.
then all the water that exited the vessel in the water pistol goes in a stream, and it all lands on your nose.
Right.
Okay.
If you're a good shot.
There's no dilution of, as long as the stream is tight and narrow. There's no dilution of it, of what came out of my water gun before it hit your face.
Gotcha.
Okay. So now, let me say, I'm now, instead of going to do it in a straight line, that's one dimension, I'm going to spray it horizontally.
Oh, okay.
Okay. But it's the same amount of water.
Same amount of water.
Okay. So if now I spray it, then it's quote diluted by the area over which it has to travel.
Correct.
Okay. So if that's the case, then it drops off as 1/r is what 1 over the distance. So if you're twice as far away, you're getting half as much as you would have if you were closer. Okay, that's how that dilution would work. Okay. So that's in 2 dimensions. Okay, now let's say you're now spraying it in all 3 dimensions, so that now it's like this wave, this spherical wave,
Right.
emanating from the water gun. Of course, you'll hit yourself in the face.
Yeah, because it's going in all directions. Right.
Right. So it turns out if you go in all these directions, then it's being diluted by the area of the surface of that sphere.
Okay. Gotcha.
Okay?
Gotcha.
So now it's being deleted, and the formula for the surface of a sphere is 4πr squared. So it's being diluted by the square of the size of the surface. And so this is the famous 1/r squared law that light experiences, that gravity experiences.
All right.
Because whatever is the source, it goes out and is filling all of space. And as it moves out, the intensity drops off as the square. If you're leaving your universe, you're going in a direction that is not accessible to anything you have seen or know.
Okay.
Because you're exiting these dimensions.
Correct.
And now you're leaving our universe, crossing into another universe. The strength of the gravity will now drop off by the cube of the distance.
Gotcha.
And that's significant.
Right.
Okay? So in other words, if I'm a foot away from you and there's a certain strength of whatever's the field that I have, now you go 2 feet away from you. Okay? No, if I'm 2 feet away and now I go to 4 feet, I now have 1/8 the strength.
Right.
Not half the strength.
Not half the strength. Right.
Because it's a factor of 2 away, and
Right.
you cube that. 2 times 2 times 2 is 8.
Right.
I have 1/8 the strength. Okay, so I don't know any reason to think why other forces wouldn't have this extra dimension of dilution associated with them, exiting your universe and coming into the another universe.
Right. Okay, cool. Wow.
Yeah, so you're subject to a higher dimension of dilution
Gotcha.
by leaving a universe. And so, yeah, so that's why I think I said in an earlier question, it's not only the 6 times our gravity that it has going on for itself.
Right.
It's got to make up for that extra dilution to leave its universe and come in here. So it's a honkering universe.
Wow. Okay, cool.
If
Wow.
if that's what we're feeling, if that's what dark matter actually is. Yeah.
Well, I got to tell you, Eric, after waiting years, you actually came up with a damn good question. Well, good for you, buddy. Yeah, we'll see.
Yeah, that was good.
Yeah, we'll see you in a few years with another great question.
Okay.
All right. Let's keep it going with. Oh, I love this. This is from Instagram. The most happy boy 11 is the handle.
Okay.
Neil, how does it all end?
Oh.
And that's it. That's the whole.
That's it.
That's the whole question. How does it
Okay.
all end?
Let me tell you what that is when we return. We got to take a quick break. And when we come back, the third and final segment of Cosmic Queries Galactic Gumbo
Yeah, that's right. Guarantee.
on Star Talk.
Okay, it's time to give a Patreon shout out to the following Patreon patrons: Kyle Marston, Caleb Martin, Zachary Zahn. Guys, thank you so much for your patronage. Without you, we couldn't do this show. And for those of you listening who would like your very own Patreon shout out, please go to patreon.com/StarTalkRadio and support us.
We back. Star Talk Cosmic Queries.
Yes.
All right. We last left off last week's episode. The question was asked by, who was it? Little Boy 11 or something? What is it?
Yeah, most happy boy 11.
Most Happy Boy 11.
Yeah.
Wanted to know, how will it all end?
Yes.
The universe will end not in light, but in dark. Not in fire, but in ice. Not with a bang, but with a whimper.
Oh, that's terrible. Poor universe.
Beyond that little bit of simple language,
Okay.
there's an entire section of the Cosmic Queries book that specifically addresses all the scenarios of how we will end. And so I'm going to pull rank here and say, buy the damn book when it comes out.
Oh, wow. There you go.
What I will do, I hate doing that, but a lot of effort went into those chapters. I'm going to pluck, for me, the scariest ending of them all.
Okay, good. I like that. All right. Wait, hold on.
okay?
Hold on. Let me get my flashlight and put that up. All right. Let's get it.
Chuck, imagining he's around a campfire
All right.
in the dark, but he's in a completely lit room. Right, okay.
Exactly.
All right, so here you go. This expansion of the universe, this acceleration, there's no reason for any of us to think it will ever end. Mm-hmm. It will keep accelerating in its expansion.
Okay.
So as we described earlier, the distant galaxies will expand beyond our horizon. Then the nearby ones will no longer be nearby because they would have been stretched to the edge of the universe.
Right.
Then the power of the stretching will overcome the gravitational binding of stars with other stars and stars with their planets. So we would see our galaxy systematically get stripped apart, with stars being cast beyond the horizon as it expands. And this will continue. So not only will every star get cast asunder to beyond our horizon, such that our sky will contain only one star, and that is the sun. Except the sun won't live that long, but let's pretend it's still there. Then the stretching of the universe will rip the planets away from the star, so that we will then become alone in our own bubble within our own horizon in the universe. Then it will keep stretching and it'll begin ripping the Earth apart. And by the way, this is happening at a faster and faster rate.
Right.
And you can calculate when the expansion of the universe rips apart the very particles that comprise matter itself.
Oh, no way.
And the what's called a Planck length, the granularity of the quantum universe itself gets ripped apart. And in fact, this is called the Big Rip.
The universe split its pants.
Split its pants.
Oh my goodness.
I mean, literally,
Yes.
It split everything.
Right. Wow.
It bent over, it split its pants. Chuck, I love that description. And that, if the universe goes that way, it'll happen between 10 to the 30 and 10 to the 35 years, around there.
Okay.
So that's a lot of years in the future.
Well,
So
there you go, happy boy. I hope you lose sleep over that.
he ain't happy anymore. No. By the way, there was an episode of Doctor Who where there was a tear in the space-time fabric, and that tear would show up, and you would like see it. And so that was particularly scary for me because I know what the theories tell us.
Right.
Yeah. So the Big Rip, freaking me out.
The Big Rip. All right.
Let it freak you out too, so I'm not the only one.
There you go. All right.
By the way, and that's just one of a dozen scenarios given in that chapter.
Oh, cool. Excellent. All right. And read it to your kids, people.
Bedtime stories.
A wonderful bedtime story. Wonderful. All right. Here, this is Chloe Wagstaff. Chloe Wagstaff says this. How can artists, in your opinion, contribute to science?
They already are. Oh my gosh. So first of all, historically, before we had cameras, especially the naturalists, but also astronomers too, if you saw something, you just drew it. All right. And not all scientists are good at drawing. So you see Galileo's sketches, they're not too bad.
Right.
All right. In his notebook, they're pretty good.
Right.
Better than I can do, I think. But if you had a real artist, they could totally rock the scene and put what is actually out there on the page. And all the naturalists who are documenting flora and fauna of the world as they traveled the world to record all the manifestations of life on Earth. Every one of those were either artists themselves or carried in artists in the back, in the wagon.
So true.
With them. And so one of the most famous of these are the Audubon paintings. All right. We hold them up as art, but this is a scientific record of birds.
Right. And
until photography could do that or do it well or capture the color of them, that was the only thing we had. So we owe a tremendous debt of gratitude to artists, the scientific illustrators of the day. But then when photography came, it sort of relaxed that requirement. But there was still some things you had to draw, because photography wasn't all that sensitive to light. So if it was really, really dim, you still had to draw it. Early astronomical images were still drawn, even though photography was available. Well, let's fast forward to today. So no, we don't, sorry, I don't need you to draw my Hubble photo, because we got really good imagery of it. Sorry. However, you know what I need you for? You know what I want you for? Design, graphic design. They're artists, okay? I like some things better than others, even if they have the same functionality,
Yep.
because some objects are just beautiful to behold or to touch or to carry with you. I value that. I think that's, we can have a utilitarian world, but is that the world you want to choose to live in? No, you want the world where that's a beautiful space. I'm talking about architecture now. That's a beautiful building, a beautiful room. It's been organized beautifully. What's the feng shui of that room? Those aren't scientists thinking that up. Those are artists.
You just described Apple computers.
Okay. I try not to mention the name because we're not paid by Apple or any computer company. But
there's still time.
There's still time.
Yeah.
So in that way, artists, I think, make a beautiful world in which scientists function. But otherwise, no, I don't see that happening. There's a big push to get A in STEAM.
Right.
Science, technology, engineering, and math. You put an A in there and STEM becomes STEAM.
Right.
And with the urge that if you train scientists to be artists, it can boost their creativity. And I don't know how successful that will be. Yes, you have to be creative as a scientist. But the number of scientists who said, I thought about this new discovery after I looked at this work of art or after I painted this, those numbers are not high. And I know of one case, a guy named Ed Belbruno, who looked at Starry Night by Van Gogh, and it got him thinking about transfer orbits between Earth and the moon because of the swirls of the paint. So it got him thinking. I think that's great. Does it mean he would have never had those thoughts without seeing the painting? I don't know. I do know, however, that science and engineering greatly affect art. Right? When neon was invented or discovered, you could have neon glowing tubes. Artists were all over it with neon sculptures and things. And so when we make chemical discoveries or discoveries in material science or in computing, the artists are all in it and all over it. There'd be no modern special effects were it not for artists exploiting the computing foundations that were created by basically math geeks 60 years ago. Right. So there is a two-way street, but most of the traffic really goes towards the artists rather than towards the science, but based on my read of the history of this.
Well, there you have it. Artists, you guys, we don't need you. Okay. Now that's a joke. Nobody.
Let me say it differently.
Nobody. Go ahead.
Maybe if more scientists took art class, then there would be more creativity expressed than they believe possible.
Right on.
Okay. Right. But I want to see that tested, and I think it's worth an experiment.
Yeah, I want to see scientists take communications classes more than I want to see them take art classes. Because that's what we need. We need people to listen to scientists. More than anything. All right.
One last bit of that. I don't want to eat up this whole segment on this, but if you look at Beethoven's Ninth Symphony or even Van Gogh's Starry Night, if they didn't create those, no one ever to be born will ever create them.
Right.
They are singular expressions of the creativity of those artists.
Okay.
Whereas if Einstein had never discovered relativity, somebody else would have, or some combination of people would have, and they would have discovered it in exactly the way he showed it to us. And so the creativity of a scientist is not existing in a free thinking way, because ultimately nature passes judgment on whether what you invented works at all. So the creative process has different landing zones.
Right. Well, that makes sense. That makes sense because science is bound by laws, whereas
by laws that we didn't create. They're out there. Yeah.
Creativity is about breaking laws.
I like it. Very nicely put.
Yeah.
Exactly.
Cool. Mm-hmm. All right. Mm-hmm. Yeah.
Let's go to lightning round. See how many questions we can get in.
Okay. Here we go. All right. I don't know if we're going to lightning round with this question because it's a great question. This is Ms. Kell, 8893. What questions are we not and should be asking about the universe? Damn! Oh, that's really cool.
All right, I got one. You ready?
Go ahead.
Okay. The question that we should be asking, and we're not, have not yet manifested because the discoveries necessary for us to occupy the new vista, which enables those questions to then be in sight of our curiosity, have yet to be discovered.
Oh my God, you thought about this before.
Next question.
Oh my God. Okay, I'm just going to say that was a really good answer, man.
Okay, next
All right,
question.
next question. Here we go. This is Vitesh Sinha, who says, do you believe in a borderless world? And how could we possibly make that happen?
Borderless Earth, no countries.
No countries.
Yeah, okay. So this
borderless Earth.
Okay, so I don't mean when world, I mean the universe, but Earth. Yeah, I think borders are embarrassing. They're just embarrassing. If an alien came down and said, "Oh, you all human?" Yeah. So well, then why is this guard raid here? Why is there a war? Oh, because even though we're all human, we're finding reasons to kill each other. But these slight differences that we tried hard to found them and invoked them as reasons to mistreat each other, to kill each other, to enslave people, to round them up into concentration camps. And so, we'd have to somehow tell that to the aliens as they look at us befuddledly, like, what the hell is wrong with you? They'll go back. There's no sign of intelligent life on Earth.
Wow.
Often a common enemy brings people together. COVID should have been that enemy, where we'd say, let's put down our differences and fight this because it will attack us all, no matter who we worship or who we have sex with or all the other things that create fights among us. We have a common enemy, people. Let's fight it together. And that didn't even happen.
Wow.
I give us a D+ on that. Okay. The only reason I don't give it an F is because some progress was made in the effort to make the vaccines. Right. So I don't have hope. I think deep down within our DNA, our tribalism will forever prevent that from happening. And I wish I could sound more positive, but based on my read of history, I can't.
Well, a sobering answer, to say the least.
I think we got to end there, Chuck.
No, get out of here. All right, wait. One last one. Very, very
One
quickly.
last one. Okay, go.
Okay, Saraba Pandov says this. Has humankind ever seen in the night sky a supernova?
Good one. So first, we discover hundreds of them a year with dedicated telescopes that go from galaxy to galaxy looking for something that blew up since last night. Okay, a supernova lasts, visibility lasts weeks and into the months. So we have dedicated experiments just for that purpose. But for the unaided eye,
Yes.
the first exploding star visible since Kepler in the 1600s was in 1987. There was a guy in the observatories in Chile, in the Andes Mountains, who was looking through his telescope, and he sees this bright object in what he's looking at, and he says, no, there's something wrong with the telescope. So he says, let me just walk. So he goes outside the telescope, looks up, and there's a bright object. Okay? So this is a case where he's using his eyes to verify the machine rather than the machine to verify his eyes. And that was discovered, I think, in February in the year 1987. It was the first supernova discovered that year, and it is the famous 1987A. And it is the most studied supernova in the history of the world. And all our telescopes, we have a very good communication system among us. All the telescopes around the world abandoned whatever research projects they were on at the time, slewed in the sky over and found this object. And even when it was below the horizon, the telescopes were waiting for it to rise. So you can get all kinds of data, radio waves, infrared, ultraviolet, visible, everything we could throw at it, we did. And there are thousands of research papers on that exploding star.
Awesome.
Visible to the naked eye.
Well, there you have it.
Yeah, Google that, 1987, capital A. It's all there.
All right.
Beautiful question. Chuck, that's it. We got to wrap.
All right. That was fun.
Yeah. Very good. So, all right, Chuck. I'll be looking for you.
It's a pleasure to be here.
I love your Twitter feed, especially when you live tweet live events.
Yeah. Not much of that going on now, but I'll be tweeting the Super Bowl. That's for sure.
The Super Bowl, I'll be looking for that.
Yeah.
Because you don't play with this. You don't cut anybody slack.
No, they're all jokes. Everybody should be able to take it.
All right. This has been Star Talk, Cosmic Queries, a galactic gumbo edition with spice on this version. So I've been your host, Neil deGrasse Tyson. As always, keep looking up.